Greetings and welcome, friendliest of friends. It is a pleasure to have you here today, my friends in real life and friends in the internet. We are talking about sloppy slope. Sloppy slope. And it says the following. It says the blank of a non-vertical line passing through 2 points is the ratio of the rise to the run. The slope. And slope was referred to as m in terms of a mathematical name for it, and it is equal to the rise over the run. It's a ratio. Ratios have no units, so those aren't like miles over hours or anything like that, but it's the change in y over the change in x, and graphically speaking, that was when we'd go up by some amount and then over by another amount. And then we would repeat that process. And because linear equations, Devin, have a constant rate of change we talked about, it's appropriate to say that their slope is constant. So there we go. Now this is interesting. I just used the word constant, but not in the sense of problem 2. It says, what is a constant function? So guys, you know that a linear let's find out. So you know, Amity, for a linear equation, it can be written in the form y equals mx plus b. A constant function would be something like y equals b. All right, or you could think about this. It was 0x plus b. And y equals b. No, I'm just giving you an example. So a constant function would be y equals a number, right? And the slope of a constant function is 0. So it has it's a horizontal line. And it has 0 slope. So Devin, you can put that away. You don't need it right now. We're going over this. Don't worry. It's a horizontal line with 0 slope is what I mean by a constant function. Also notice that it's lacking a variable in it, right? It's missing the x. The x is the thing that causes a function to change for its different values, where this is just always the same. All right, let's take a look at these. So reading slope off of a graph, I'll do this a couple different ways for problem 1. So I'm interested in finding lattice points. Those are points where it crosses your grid right in the crosshairs exact. And the slope is going to be how much change, what would I have to go up by and over by to get from one point to the next. And it looks as though this is going up 4. Wait a minute. Up 1, 2, 3, 4. Okay. And over 3. Unrelated to these 4s and 3s in that way. So the slope is 4/3. And if I wanted another point on the line, I actually could go up 4 and over 3. And we did that Desmos activity the other day of putting the point on the line is the idea of what we did. Another way you could find slope, and I want us to be very aware of this, was using the slope formula. M is equal to y2 minus y1 over x2 minus x1. So if I label this point x, I'll call this point 2, x2, y2. And you can call either point either name, but once you pick it, this is point 1 forever. Forever. We gave it its name. Oh, it's adorable. So the slope is going to be y2, which is 3, minus y1, which is -1, over x2, which is 4, minus x1, which is 1. So I'm going to have m is equal to 3 minus a -1 is the same as 3 plus 1. 3 plus 1, my friends, is 4. And 4 minus 1, I think you guys agree, is 3. So whether I used the graph and read rise over run, or used the slope formula and the coordinates of those points, I should get the same thing. Now let's see. Ethan, you'll tell me, what's so funny about this problem 7? What is the rise here? What's going on? How far up do I go? Or maybe let me ask this way, because you just told me 0, and that's a weird number. How far down do I go? Maybe the rise is falling? No, he's right. I'm going up 0 and then over any number, really, but in this case, over 4. So the slope would be m equals 0 over 4, or m equals 0, right? And we just talked a moment ago that horizontal lines have a slope of 0. This is a horizontal line. Does anyone, let's see, does anyone know the equation of that line? We were graphing those 2 days ago. 2 days ago. The equation of this line, is it x equals or y equals a number? It's actually going to be y equals -3 would be the equation of that horizontal line. Yeah, that's a little flashback right there for you. Let's see, question 10. We also were able to find slope using tables. The rise is just going to be the change in the y values. And that's zero, I think, is what I've seen. Yeah, all right. And the run is going to be -1 to 2. How far did that run? Looks like 3. I'm getting, man, yeah, with the dance moves. So rise is 4. That's not a 4. That's a 0 over 3. And so the slope is 0 here. And notice for a 0 slope line, notice that the y just never changes. You could also refer to this as a constant function. Man, it's like these keep showing up. A constant function, yeah. Because basically that's saying, like, I input -1, outputs -6. Input 2, outputs -6. Input anything, the output's -6. It's like it's constantly telling me the same thing. All right, let's see. So, Jimmy, if I wanted to find the rise here, the rise is going to be the change in the y. Oh, dear. Uh-oh. Now, if I didn't like these 2 points, I actually could pick any 2 consecutive values in the table. What's the change in the y? What are you thinking? Yeah, subtracting 7. It's going down 7. And what was the change in the x there? It's going up 1. All right, so the slope for this one is going down 7 over 1. So the rise over the run. And when rise is falling, we would call that a negative rise, right? And a slope of -7 over 1, you can write it that way, but you also could just call that m equals -7. Question, comment, observation, stretching? Just stretching. All right, good to stretch. It's good to stretch. Good to stretch. One last problem that I've picked for us to look at. Ooh. Nice. You want to walk me through some thoughts, or? Okay. All right, so I like that. So Pooja just said that the rise would be the 120 minus 60 is how you could calculate that, and I think I agree, right? And the run would be the, this is at 2 on the graph, and this is at 1 on the graph, and 2 minus 1 gives me a run of 1. So I get a slope of 60 to 1. Yeah. Same thing, Amity, if I used the slope formula, I could plug those points in and that would have given me the same thing. And I like that idea, right? That you see, I'm not just counting boxes, but the way I could find the rise is by subtracting those y values, right? It just makes sense. Question, comment? Yeah. Also, they asked us to interpret the slope of the line. And notice, what was 60 measuring? What was the y measured in? This is the same as 60 miles, and the run was measured in hours. And notice the slope, that's the same as m equals 60 miles over hours, or miles per hour. What's interesting here is this graph represents distance compared to time. It's a correlation between those things, but the steepness of the line represents the speed. And that is such a cool concept. That concept, actually, you could take that all the way to calculus, my friends, talking about the slopes of things. right? So here I was talking about position and time, or distance and time, and the slope represented something completely different. It represented speed. All right, well, thanks for watching, Internet friends. Have a great day.